Let's look at this problem. The ages of Johnny's 4 cousins are distinct single-digit positive integers. 2 of the cousins' ages multiplied together give 24, while the other 2 multiply to 30. What is the sum of the ages of Johnny's 4 cousins? And for this problem, we can interpret all the wordings into some mathematical formulas, right? So let's say the ages of the 4 cousins are x, y, z, and w. And therefore, we know that xy equals 24 and zw equals 30. Therefore, we know that there's no way to solve this system of equations directly. And this is because we have 4 unknowns and only 2 equations. However, this is not a general equation because all these numbers belong to integers. Then we have ways to solve this system of equations, and the major tool will be prime factorization. And such knowledge is almost a must-know in the AMC10 or above contests. Therefore, you have to be familiar with such techniques. And let's look at these 2 integers. The first one can be factorized in this way. It equals 8 times 3, right? So 8 is 2 to 3, and then times 3. That's 24. And the 30 equals 2 times 3 times 5, right? And at the same time, we know that all these 4 variables are single-digit positive integers. So this is a very crucial indication. And let's start from the second equation. And some students may wonder why. This is because we have a special prime number in here, which is 5. And for this special prime number, any multiple of it will be at least 10, right? Unless you multiply it by 1. Otherwise, you get a minimum of 10, which is already a 2-digit integer. Therefore, one of the solutions, let's say w got to be 5. And then z got to be the product of 2 and 3, which is still a 1-digit integer. Therefore, z equals 6. So here is a very nice starting point, right? And don't forget, none of these numbers should be identical. All 4 numbers are distinct. Therefore, from the first equation, we can't have a 6 now. Then let's think about this 3. So there are a couple of choices for 3. Either one of the cousins' age is 3, or a multiple of 3. And at the same time, we can't use this multiple of 6, which is 2 times 3. Then the very next larger multiple of 3 would be 12, which is a 2-digit integer. Therefore, we can't afford a multiple of 3 in this place. Then one of the cousins has to have an age of 3. Then let's say y equals 3. Then the last step will be very easy. X will just equals 2 cubed, which is 8. Therefore, we got the ages of all 4 cousins. And in the question, it's asking for the sum of the 4 numbers. Then we know that 6 plus 5 plus 3 plus 8. So this gives another 8. So 2 times 8 is 16, plus 6, that's 22. Therefore, 22 is our final answer. So we want to choose B, 22. If you like this video, please give it a like and subscribe the channel. If you have questions, please leave a comment.